model. Okay, let's go back to where I was. Yeah, so we might want to have a quadratic term in the model. Okay, so we have counts, so Poisson model. But we want to take account of this exposure factor. We're really interested in the rate per person year, so the rate per exposure, rather than the actual parameter of the Poisson distribution, which will have that information about the exposure included in it, and so would be essentially fitting something which depended on the exposure rather than the death rate, which is what we really want to model. Okay, so here's our Poisson model. So the code for fitting this will be on the next slide. So we have our offset, log of the exposure. So the TI here is the number of person years. Constant term. Then this is 1 for smokers and 0 for non-smokers, so it's a factor variable. This is the age category, converted, so basically an approximation to the age, 40, 50, 60, 70, 80. Then we have a squared term in age here. And we also have an interaction term between smoking and age here. Okay, so that's our model. Okay, so it gives separate quadratics, but has the same coefficient for the squared term. Okay, so here's what we get. So we need that offset because we didn't have a beta term multiplied by log of TI. So we have offset of the log of person years. So that tells R to fit it with the known parameter 1. And then we have an interaction between smoke and age and the age squared term. Okay. So this works remarkably well. We have 5 degrees of freedom. So there were 10 observations. We fitted 5 parameters here. There were beta 0 to beta 4 in the form of the model. So we have 5 degrees of freedom. And our deviance is really tiny. That's pretty small for a chi-squared 5. Mean of a chi-squared 5 is 5. So in fact our fit is better than we might expect. And if you look at the summary, you'll see that all the terms in the model seem to be necessary. So there's no sign that we've got some unnecessary parameters here. Here are the fitted coefficients. So our linear predictor is one form for non-smokers and a different form for smokers. You can see that it starts off lower for non-smokers, so a smaller value there than there. It actually increases slightly faster for smokers, which fits with the plots that we had. Okay, so here are the plots again. So I've already talked about the top right plot. These are the plots giving fitted values, and then these are residuals here. So the residuals are mostly pretty close to 0. In fact, this one here, minus 0.4, that's really not very far from 0. So even though it looks like it's a bit of an outlier, it's not something to be worried about. Okay, and the bottom left plot here, you probably can't see it very well on the screen. Hopefully you can see it in the notes. There are triangles and dots here. So the triangles, we should check which way around it is. The triangles are the observed values, the dots are fitted values. But you can see how good the fit is, because in fact every dot is inside the triangle. So they're very close to working. Okay, so that's gone through chapter 5. So next week I will do chapter 4, which is the binomial regression one.